Oh, I think we should. Nope. Okay, you're gonna need page 3 on your knowledge folder out, or your paper. You're gonna need page 3 because we are talking about proofs again today. Page 3. That's what it has on there. We wrote those down yesterday. Okay, so this lesson is about proofs. So we have done some proving. We're going to add a few more proofs. Wow. Proofs. There we go. Proofs. We have done some proving. We're going to add some more strategies to our repertoire of proof things that we can do, and do get a little bit more complicated. Okay, so we've got the basics. We're going to add a few more strategies and then do a decent amount of practice. So that's what we're looking at today. We're talking about proofs. So we've already talked about some strategies. Okay, we've already talked about some strategies. So if I give you a proof, this is from chapter 4. If I give you a proof, what are some of the strategies you could do? Yep. So you could substitute some dogs. Correct. Hold on to that thought. Substitute for any dogs. You can also rearrange or regular. So I'm going to put rearrange up there. Trevor said change everything to sines and cosines. Okay. Anything else? Which is what you would use, changing your things to sines and cosines. So you're correct. You would use the quotient identities. These ones are a little, you would do them anyway. You just don't think about doing them is all. We've talked about the fact that you can distribute if there are parentheses. And we've also done a little bit of fraction math, right? Like we've done divide the fractions if we need to divide the fractions. Okay, so fraction math. So those are the ones that we have done so far. You guys are pretty proficient at those. So we're going to add a couple more pieces in. Okay, so the first one I want to talk about actually falls under the heading of fraction math. All that we've done so far is dividing, really. But there's another couple of strategies that make fraction math really useful. Okay, so there's just going to be more strategies, I guess. So this strategy is, we're just going to call it splitting the fraction. So this only works if you have a single term on the bottom. That's called a monomial. Today's keyword is kangaroo. For those of you watching later, if you tell me what the keyword is, something fabulous will happen to you. If you don't, something fabulous will happen for everybody else. There you go. I don't know what fabulous is. But so let me give you an example. This is not going to, we're not going to put it in a proof, but I'm going to show you the example. So let's say we had sine x plus, let's go, well, it doesn't matter. Okay, so when you have this fraction with one term on the bottom, okay, when you have that, what you are allowed to do is split this up into two separate fractions. They both have to have the same denominator, though. Okay, that gives you more things you can do. I can't really do a lot with what's there. When I split them up, then I can be like, oh, this is 1. And then I could keep switch flip this. I could turn this to sines and cosines and do some other things, okay, which we're not going to do because this is not a proof right now. Okay, but this is a legal move. And it's true because I could go backwards. These are 2 things with a common denominator. And if I added them, I would add them and the denominator stays the same. So I'm undoing a common denominator is basically what I'm doing. Sometimes that's very helpful. Okay. Do you have to? Nope. There's almost always more than one way to do these things. But that's another way that you could do it. Okay. We're going to do a whole bunch of examples, but I just want to give you, like, what does it look like? The next thing that is a possibility is you can undistribute. I'm going to say undistribute common pieces. So let's say you have this one will actually get us somewhere. Sine squared plus, nope, we're going to go minus sine squared cosine squared. So this is a situation, if you saw this in a proof, like everything's already in terms of sines and cosines, that strategy isn't going to help. By the way, that's almost always the first thing I look at. Like, can I put everything in terms of sines and cosines and will it help? This time it's already there. So you can't really do anything with it. But if you look at your 2 terms here, they both have a sine squared in it. So just like we were practicing factoring yesterday when we were like pulling numbers out after we were doing the voodoo method, when you pull numbers out, you can pull a sine squared out of this. Okay? So if you pull a sine squared out of this, undistributing, what's left in the first piece? 1, not 0, just so you know. 1. There's a minus because it's a minus there. What's left in the second piece? Cosine squared. Now look at what that lets you do. We know what 1 minus cosine squared is. It's sine squared. So do you see that it actually lets you get somewhere if you undistribute? What would this be? Sine to the 4th. Yep. Sine squared times sine squared is sine to the 4th. So you can undistribute pieces that are in common like that. And sometimes that's the only way to do it. By reversing the distribution, and then you can get somewhere because of what's left. Just a second. Got my notes are all over the place here. Okay, so this one goes back to fraction stuff, kind of like this, and I've said it a couple times, but we'll write in our notes. If you see a common denominator, use it. Okay, so let me give you an example. Let's say we've got tangent squared times secant plus nope. Sorry. Let's go secant squared. There we go. Okay, so you're going to say to me, hey, there's no common denominator because there's no fractions, Mrs. Douglas. Right. I agree with you. What can you do to tangent, though? Turn them into sine over cosine. Okay. What can you do to secant? 1 over cosine. Now, this does not help us a lot because I didn't look at what we got going on, but that's okay. This is just my example. We're not going to get anywhere with it. Look at the fact that because I turned them into sines and cosines, I reveal that I have a common denominator. So I can, when you add fractions, you add the tops and the bottom stays the same. So it's kind of the reverse of the first one that I gave you where you're splitting a fraction. If you have a common denominator, a lot of the times it's there for you as a gift and you need it. So take the gift and use it. Is the top one a dog? Is it rearranged? Is it the rearranged big dog? Why? Because I'll have to have a minus, right? The big dog is 1 minus sine squared. So I was not paying good attention to that, but that's okay. So the other thing is that you can create a common denominator. So I have an actual example for this one. I got to see if I can find it. 54. Okay. Okay. So let's say that we have this example. This is fraction math, more fraction math. We got a lot of that really is what we've got. Fraction math, fraction math, fraction math. So let's say we have sine of t plus cosine of t cotangent of t. Why t? Why pull this out of the book? Why they use t? I don't know, because it just blends into the cotangents. That's stupid. Okay, so sine is already sine. Cosine is already cosine. The only thing I can do is change cotangent. Cotangent is cosine over sine. There's literally nothing else to do here. And so you go, well, I don't even know what to do. Here's my thought to you. This is a cosine squared, right? If I have a cosine squared, it's probably a good indicator that there's a dog involved, but I don't know how to get it. Like, that's the point. If I was you, I'd be like, I have no idea how to get this. Watch what happens though. If I'm like, hey, what if I try to add these? If you're going to add fractions, you have to have a common denominator, right? So what would the common denominator be? This is not a rocket science question. Nope. So it would be sine, because this is the denominator this guy has. Okay, so common denominator means this guy also needs to get a sine on the bottom. And when you put a sine on the bottom to do a common denominator, you also have to put a sine on the top because you're multiplying by 1. Okay, so common denominator, we will go over and practice this with fractions in just a hot second because obviously it's been a hot minute since that. But now look at the top. What is the top of this fraction? Yeah, so we have sine squared over sine plus, that was cosine squared, we already talked about that, over sine. Now because I have a common denominator, I can add them. So what does the top is sine squared plus cosine squared? The bottom is what? Sine. So when we add fractions, the bottom stays the same. Now, what does the top equal? 1. So that's 1 over sine, which is cosecant. Okay, so let me just give you a little bit of Let me just give you a quick review on a couple more just much easier common denominator questions. No t's. And we're also not using sines and cosines because why do we need to do that? Okay, so let's say I asked us to add these two things. What's the common denominator? Easiest way to do okay, then obviously it's been a long time. Easiest way to do this is to mush them together. So common denominator is 5x. So if we're going to make the common denominator 5x, I need to put an x here. If I put an x there, I also have to put an x on the top. Okay, because x divided by x is 1. And you can always multiply something by 1. Okay, if I want this to be 5x here, then I also have to multiply the top by 5. Difference being that there's actually a number there. Okay, so then when I add them, it's 4x plus 15, because 4x, 3 times 5 is 15, all over 5x. Okay, so let's try another one. Let's say we've got 7 over y plus 3. Now, if you're like, no denominator, I don't like this, what's the denominator on the 3? 1. So there's the mush them together. Common denominator is 1 times y. So that goes back to thinking about the sine one that we did a minute ago. It's 1 times sine. There was no denominator on the other one. Okay, try this one for me. Okay, so common denominator is what? Y. This already y. So I don't need to change this one. If you want to, it's 1y, and you can be like, I'm multiplied by 1, but that's pointless math. This is y. So final answer is 7 plus 3y over y. Okay, that's common denominator, which I know it's been a long time since we've done those. Two more strategies I want to talk about. The first one kind of goes back to our other things that we have. We're going to do a couple of these because there's not very many in the book. So up here we had that you can substitute for the dogs. Like we know that. You can substitute other pieces also. We just haven't really used any others. Okay, let me give you an example. I really love these ones. They make me really happy. So let's say, here's an example. Let's say we have the cotangent of pi over 2 minus x times cosine x is equal to, we're proving this, is equal to sine x. Okay, so this bit right here is something that we've not done in proofs before, but where have you seen that? We did it yesterday. We literally wrote those down. And so I told you we would use them. This is how you would use them. This cotangent of pi over 2 minus x or theta or whatever variable it is can be directly removed and replaced with tangent. So if you see something with the pi over 2 minus the variable, that's a cofunction identity, and you pull it out and replace it with tangent. So this thing here is tangent of x times cosine of x. Now you have a regular old proof again. Like, this is an easy one because we're going to turn our tangents into what? Yeah, sine over cosine. So sine over cosine times cosine over 1. What happens? Cosines cancel, and then you just have sine. I like those. I think I like those because I feel like this looks terrible, and I just like to change it and make it look better. So try this one. Oh no, try this one. Okay, so let me give you another example of this though. So let's say, I have to think about this. Here's another example. Okay, tangent of negative theta times sine theta is equal to negative. You guys, I'm making this up in my head. It might be wrong. Nope, it's wrong. Change this to cosine. And this is sine. I'm just going to make them up as I go. Okay, so tangent of negative theta, cosine theta equals negative sine theta. Okay, so again, we've not had a negative theta in our proofs at all, but it's on your paper. What is a negative tangent of negative theta? What is that equal to? Yeah, it's next door. It's an even odd identity. This takes the negative out of there. So negative tangent times cosine. Wow, I should have totally just looked up there. Now, really, it follows this whole steps up here. We've got negative sine over cosine times the cosine. Those cancel, and that's negative sine x. Okay, so that's what I mean. Like, you can substitute other identities. It doesn't have to be the dogs, just the dogs. But I will say the difference between these guys and the dogs is that these don't have to be rearranged. Okay, like, because this is just a one thing. There's no rearranging. Yes, Andy. Can you explain where the fraction comes from? This fraction? What's tangent? Tangent, that's the quotient identity. So on your paper, quotient identity, tangent is sine over cosine. Okay. Okay, now, last one. The last of the new strategies is, when we were doing this before, I told you that you cannot cross the equal sign and you should pick only one side. Okay? Sometimes, I want you to listen to me very carefully. You can make both sides equal each other. So see if I can come up with a good example. Just a second. I don't really have a good example right now. But if you have something over here and you're like, this is really complicated and I'm going to work with the left-hand side, but then the right-hand side is not exactly what you want it, it's okay to do the left-hand side as far as it goes, do the right-hand side as far as it goes, and if they're equal, then you're done. You cannot still cross the equal sign, okay? You're not allowed to cross the equal sign, but you can do one side, do the other side, and make them equal each other. The only example I have in the book is ridiculously difficult, so I don't really want to do it. Let me see, just a second. If I can find one that's not ridiculously difficult. No, I don't. It's terrible, is really what we've got going on. This we don't use very often because they're usually difficult. And so I don't tend to give you ones that are that difficult, really, is what we got going on. But I will, as we're doing our examples, when we get to one like this, I will make sure that I show you one. Okay, so here we go. Let's start some examples. We have a lot of strategies now. So as we do these, I'm going to just point out what strategies we're using so that you can look back and be like, oh yeah, I see that. Let's do this one. I like this one. I'm a fan. Plus sine x cosine squared x equals sine x. Okay, so everything's already in terms of sines and cosines. There's no parentheses. You can't multiply anything. This is one that has to be done with the new strategies. And the only thing that we have anything with fractions. Okay, the only thing that you can do is what? Yeah, you can undistribute a what? One of the signs. So that's all you can, that's literally all you can do. There's no other way to do this one. But once you do, this problem is really easy. Okay, so if you pull a sine out from sine cubed, what are you left with? Yep, so sine squared. If you pull a sine out from the second one, what are you left with? Now, you guys, as we do these, some of you, maybe not all of you, some of you are like this is like the worst teeth pulling thing in the world, Mrs. Douglas. It's so hard and it hurts. Some of you, though, will get to the point where before you're done, you can be like, I see where this is going. And it's a really nice feeling because you're like, I know what I'm going to do. What are you going to do? Yeah, this is a big dog. It's just one. Right? So this is sine x times 1, which is sine x. There you go. Because it's the big dog, you don't even need to rearrange it. It literally is just equal to 1. And there's your sine x. Let's do this one. This one's going to be significantly longer. I mean, it's not like pages and pages, but so cosecant x plus cotangent x times cosecant x. Ugh. I feel like that's wrong. Just a second. I feel like that's just a second. Cosecant, cotangent. Yeah, that's not right. Okay, we'll skip that one. I got to see if it's right. Here, you guys, give me a couple lines there, and then, or erase and rewrite, whatever you want to do. You guys try this one. I know you can do this. We've done this type of problem already. So secant squared minus 1 times cosine squared. equals sine squared. Okay, you give that a shot and I'll see what happens if I finish this guy. It's not wrong. Yes, it is. Okay. What's the first thing you're going to do down here? Yeah, this is a little dog. Secant squared minus 1 is equal to what? Yep. I feel like we keep doing tangent times cosine today. So tangent is sine over cosine. And cosine over 1. Cancel. And that equals sine squared. Okay, we'll go back to this. I had a negative problem. It was a bad problem. It would have been terrible. There we go. This should be equal to 1. Okay, so what are you going to do? What are you going to do here? You got two choices as I see it. That's one of your choices. You could distribute. Your other choice is to turn everything into sines and cosines and then distribute. Listen, you can do that, but why would you distribute fractions if you don't have to? That's my thought. Yeah.
Can't you just do little dogs, determine negative ones, one times negative one is 1?
Okay, so the answer to that is no. Why can we not turn this into little dogs? That's a question for everybody, not just Grayson. Okay, there needs to be a negative in there, and it's not squared, right? Like those dogs have to be things squared. So good question. So the dogs have to be squared. So let's distribute. This is cosecant x, it's cosecant squared. We know what cosecant is. This is minus cosecant x cotangent x plus cotangent x cosecant x minus cotangent squared. By the way, this is one we would have done in the last chapter also. I don't know if we did it, but it's at that level. What are you going to do there? Yeah, you can cancel the middle ones out. Right? These are opposites. I've got each of these has a cotangent and a cosecant, so you can eliminate those. Okay, so you've got cosecant squared minus cotangent squared. It is a dog. Now, I don't know. Like, some people do not like to rearrange the dogs. So let me give you another option. If you're like, hey, I know this is a dog because it's got a cosecant and a cotangent, I don't want to rearrange. You have another option. You could just substitute 1 plus cotangent in for cosecant. That's legal. Okay, I'm going to show you. I would probably not do this, but this is 1 plus cotangent squared right here. This is minus cotangent squared. What's that equal to? It's 1. It's an extra step, but if you don't like the rearranging, you can just substitute that in and then just do regular math. Okay. Let's do, I lost it. I had a really good one. There it is. Okay, that's an X. Okay, what do you want to do here? That's the equals, by the way, not a minus on the end. It's equals sine X. This is actually really not bad at all. What are you going to do? So let me ask this. Can you factor anything out of that? So the first term is a cosecant, right? Is there a cosecant in the second term? Then you can't factor. Okay? So your only choice is to turn everything into sines and cosines. Okay? Turn everything into sines and cosines. There's a 1 over sine. Just cosine over 1. Cotangent is cosine over sine. Okay, so we talked about the metaphor of reassembling the Lego blocks. Like you take it apart and you reassemble it, it looks different. What does this equal? Now, here's a situation. You do not have to create a common denominator, but there is one. So if there is a common denominator, 99 times out of 100, you should use it. Okay, so if you use the common denominator, what's on the top? 1 minus cosine squared. On the bottom is sine. Now, this is where life gets easy. What's 1 minus cosine squared? Sine squared. Okay, and then what's sine squared divided by sine? Sine. And you're done. Because sine is sine. Okay, here is one of the ones, I told you I'd point this out to you. Here is one, well, let me write it down. So you've got sine squared x times tangent squared minus 1 plus 1 equals tangent x over cotangent x. Now, this is one of the ones where I don't know, like I'm going to tell you as a teacher, I look at this and I go, oh, I don't know how I'm going to get this. So maybe I need to work the left-hand side and then I need to work the right-hand side separately and see if I can get them to be equal to each other. Okay, so that's how you're going to do this. You're just going to take this guy and you're going to simplify him as far as he will go. Okay, so the thing I would do here is, this is a dog. What's tangent squared plus 1? Yeah, secant squared. You could distribute this if you want. I am not gonna. I would just do that. So it's tangent times secant. And then I would turn my secant into cosines because secant is 1 over cosine. So 1 over cosine squared. Okay, what is this? Right, it's sine squared over cosine squared, which is tangent squared. So the question is, can I get this guy to be tangent squared? So this is how you do if you work with one side and you work with the other side. This guy, I would turn him into sines and cosines, right? I mean, there's more than one way to do this problem too. So sine over cosine divided by cosine over sine. And I'm going to keep switch flip. So sine x over cosine x times flip. Okay, what's that equal? Sine squared over cosine squared, which is tangent squared. Okay, so this is what I mean when I say you do one side and you do the other side, and if they're equal, then you're good because you just proved that the two pieces are equal. But you can't cross the equal sign. Goodbye.